I want to take a few minutes to connect some of our ideas from chapter one or module one, this idea of sampling, studies, observational studies, experiments, and kind of these terms that we're getting introduced in this section to some real world ideas. And so first I want to take a look at this example of an observational study versus experiments. You will see here in the data, you'll see some graphs, bar graphs, stacked bar graphs, and it's the percent of papers published in academics for science, engineering, physics, right? You will see that more published by males than females. And so some key terms that you're going to be introduced to, or maybe you've already gone through, is what would you think, what variables would lead to having this disparity, right, in publishing between them? And again, I have some stuff written in here. This is not from the class. This is just some ideas to share with you. So to help build more context for that material in module one. Think about what would happen here. One possible explanation, again, is maybe there is a hiring bias, right? That women are given fewer opportunities. That could be one conclusion, right? Based off of this data, right? But what we learn is that from this data alone, we cannot prove, right, there was hiring discrimination, because there could be other variables, what we call confounding, right? Other alternative explanations when we think about why this would happen, right? It doesn't mean there isn't hiring bias. They could be hiring bias, right? But again, just because the data has some story, right, we have to then find out what it is. The numbers are the numbers, but then we have to figure it out. And what are some alternative? Is that fewer women pursue these fields potentially, right? But that also could be because maybe they weren't given certain opportunities, or there was bias, right? So it gets all kind of confusing, and that's where we get this the confounding issues, right? But I want to make sure you have some thought about it. And here's an example of kind of these variables, and not always being able to draw conclusions. It could be hiring bias, but we have to kind of look deeper into some of those reasons, right? So I want to make sure we introduce that idea. I also wanted to show you a short video. Let me pull that up real quick. Thinking about this idea of studies and what conclusions can we draw from the statistics that we encounter in the world. So let me pull this up real quick. Here we go.
Might fuel the growth of cancer. A new study shows late night snacking could might fuel the growth of cancer. A new study shows late night snacking could damage the part of your brain that creates and stores memories.
A new study finds pizza is the most addictive food in America.
A new study suggests hugging your dog is bad for your dog.
A new study showing that drinking a glass of red wine is just as good as spending an hour at the gym.
What?
So when we talk about these studies, we have to then decide, right, is this an observational study or is it an experiment? Also in that information on those clips and this news, that news actual organizations look for these types of studies. They have certain places they go, but many of them don't look at the details, right? They don't define what those variables are, right, as you have all these conclusions. And additionally, you want to know that it's through one study is not enough to explain, right, to come to some conclusion. Also, that you need to know is that experiments, right, are the way that you want to show some causal relationship versus observational studies. And those difference, again, experiments, you alter, right, you do something to the variables, right, you control for them, versus an observational study, you just look at data, right? You like this here is an observational study here where you look at data. And then you analyze the results. And through observational studies do not allow us to draw conclusions that are what we call causal relationship, right? This idea that there's correlation, but does not infer causation, right? And so it's important in all those studies, they're just taking some point and they haven't defined what those variables are within those studies. And many times when you read them, again, many times those headlines don't match up exactly to what the findings are, or that it's just one little piece of the study, right? And it will take multiple, replications of those studies to really, for us to come to a conclusion that hugging a dog is bad for your dog, right? We have to define, what does it mean to hug? How often do we hug, right? There's all these variables that come into play that we don't have, right? And we just take those, and that's what people walk around with, right? One more piece important in this section is sampling. Let me pull it up here. And so this was about 2 minutes, and this is from ABC News back in July, I think it was. And so just listen to the different sampling techniques that are going on to try to estimate the percent of a population that is already tested positive for COVID, okay? So this is 2 minutes, so hang with me.
Josh, thank you. A new antibody study shows Riverside County may have substantially more cases of COVID-19 than previously thought. This despite the fact that Riverside was the first county in the country to mandate wearing a mask. Inland Empire Bureau Chief Rob McMillan has more on what the numbers mean.
Just listen to the
For
techniques.
the past several months, COVID-19 testing in Riverside County has been, for the most part, voluntary. In other words, the only people getting tested were people who were either feeling sick or people who went through the trouble of getting tested, even if they didn't think it was necessary. That can certainly skew the numbers, something Dr. Cameron Kaiser said they wanted to avoid with this survey.
We tried to make sure this was as random a sample as possible. We actually actually hired a public relations firm to go through addresses and try to pick a good, even mix of populations, of geographic areas, and then we reached out to those people instead of them reaching out to us.
Of about 3,500 people contacted, 1,726 people were tested, 101 tested positive. That's a positivity rate of 5.9%. That means somewhere between 118,000 and 175,000 county residents have already had the virus. Dr. Kaiser says there are things this survey does not tell us.
It doesn't tell us that these people are immune. We don't know how good those antibodies are. We don't know how long they'll last. I certainly hope that they're immune because that would tell us that the vaccine candidates out there are on the right track. But nobody's proven that yet.
But if about 6% of county residents have already had COVID-19, that means about 94% of them haven't.
The vast majority of people in Riverside County have yet to have COVID-19. And that means that if herd immunity even exists for COVID-19, which is by no means certain, we're nowhere near it.
And Dr. Kaiser says if you simply run the numbers, take the number of people who died, compare that to the total number of people who they think have had COVID-19, the fatality rate right now in Riverside County is between 0.4 and 0.6%. That's at the lower end of the CDC's estimate of 0.5 to 1.
So that's very interesting in terms of, again, those sampling methods. I would want to go back again. Go back and listen to that piece. Listen for voluntary samples, right, and the issues related to that. He talks about that voluntary samples could skew the data, right? They did a survey, right, where they go out and then contact individuals randomly, and he said they were looking for an even mix, which means a representation, right, a representation of the population. What they're trying to do is see if the sample tells the story for the population, right? And they were looking for non-volunteers in this mix, right? So they sought out. And then, again, hoping to tell the story, and they do that number where if it's 6% of the people, right? These are people, they went out. These weren't the people that came and get tested. So people are walking around the community with COVID and not getting tested. And that's what they were trying to do. And then they did a quick estimate of then what percent. In the end, it's very important that percent, the mortality or fatality rate there, they talk about 0.5% seems very small, but 0.5%, just keep in mind, is 1 out of 200 people. So just keep that in context. So hopefully some of this helps. Go back and look what you need to, but there's some key ideas here in what I just showed you there that connect to Module 1.